Hello friends, now we can start our experiment number 7. This is experiment number 7 and this is the test for population mean. So in this test for population mean there are two examples. See, these are the two examples, problem 1 and this is problem number 2. First read the problem number 1 and then we can see how to solve this example. So this is the example which is related with test of population mean. There are 7 envelopes and a random sample of 7 envelopes is taken from letterbox of a post office and their weights in grams are found to be. So these are the weights of the envelopes. Does this sample indicates at 1% level that the average weight of envelope received at this post office is 12.25 grams? So how to solve this? To solve this, first we need to write the aim. So what is aim? To test whether the average weight of envelope received at post office is 12.25 grams. So that is my H naught in this case is 12.25 gram. So what is the formula? See, the formula for this is P is equal to X bar. This formula we have to apply. X bar minus mu naught divided by S upon root n follows P with n minus 1 alpha. And what is this S square? This is sample mean square. That is summation x minus x bar square divided by n minus 1. So these are the values. How to calculate? So see, these are the 7 values we have given. These are the 7 values. See, this is n is equal to 7. And what is mu naught? Mu naught is also known 12.25. So how to solve this test for population mean? The procedure is first write down the values of x. So x in this case is the average weight of envelopes and then square it. See, these are the x values 12.1, 11.8 and all these values are given. So what we need to calculate? We need to calculate summation x. Calculate this value and then square the values of x. So see, this is 12.1 square is 146.41. The next is 18.1. The square of this value is 146.41 and then add all these values. So what is the addition? So addition is summation h square is 1225.88. Then calculate the value of mean. First calculate this. How to calculate the value of mean? Mean is summation x upon n. So the value of mean is summation x upon n. Summation x is known, n is known. The value now comes out to be 13.0571. Then calculate sample mean square, S square. Summation x minus x bar square divided by n minus 1. And this value, so if you calculate this value and take the square root of this, that value comes out to be how much? See, this is the value. This value is small s. So this is 2.325828. So what is the procedure? The procedure is, so H naught. So H naught is mu is equal to mu naught is 12.25 gram versus mu which is not equal to mu naught. So that means the value in this case, that means the average weight of this value is not equal to 12.25. So since it is a two-tailed test, fix the level of significance. So alpha is 0.01, so that is given. And under H naught, this is my test statistic. So what is the test statistic? So this value. So this is the formula. T is equal to x bar minus mu naught divided by S upon root n. So put all these values. So x bar is known. So this is 13.05. So mu naught is given 12.25. S is, we have calculated the value of S, which is square root of S square is 2.32 and the value of n in this case is 7. So that is square root of 7. So what we are getting? So we are getting this value as the calculated value of P is 0.9181. And what is this value? So table T. So table T can be obtained such that for two-tailed alternative, so probability of mod T greater than or equal to Tn minus 1 alpha by 2. So why we have taken this alpha by 2? Because the case is two-tailed test and the level of significance in this case is 0.01. So table T at n minus 1 alpha by 2, n is 7, 7 minus 1 is 6 and alpha is 0.01, so that should be divided by 2. So the value table T at 6 and 0.005. So let me show you the value. See, this is the value. So n is equal to, in this case, n is equal to 6. So this is the value. N is equal to 6. See the value, n is equal to 6. And then see the value 0.005. This is the column. So the value which comes in the intersection is how much? 3.707. See, this is the value 3.707. So that is my calculated value of table value of T. So what is the calculated T is 0.91. Table T is 3.707. So therefore calculated T is less than table T. So we can accept H1. So what is my conclusion now in this case? My conclusion is the average weight of envelopes received at this post office is 12.25. So this is the null hypothesis and we can accept this. So take the second example. In the second example, first read the example. So a machine is designed to produce insulating washers. This is 0.025. A sample of 10 washers are given and the average thickness is 0.024 and a standard deviation of 0.002. Test the significance of the deviation at 5% level of significance. So what we have to do in this case? So to test the average thickness of insulating washers for electrical devices is 0.025. So mu naught is 0.025. Use the same formula. T is equal to x bar minus mu naught upon s upon root n follows T n minus 1 alpha. N is given. See, the value of n is given and the value of mu naught is also known. This is also known and the value of x bar is also given. So what is the value of x bar? This is the value and the value of s is also known, 0.002. Apply two-tailed test. Fill all these values. What we are getting? The calculated value that we are getting is 1.58. And what is the table value? So the table value in this case is, the table value is table T is equal to table T n minus 1 alpha by 2. So n is n minus 1 is 9 since there are 10 observations and the level of significance is 0.025 and this value is 2.262. So if you see this, this is 9, this is 9 and the value 0.025 is how much? See, this is the value 0.025 and the value which intersect is 2.262. So just I am locating this value. See, this is the value 2.262, right? So what is my calculated value? The calculated value in this case is 1.58. The table value is 2.262. So what we are saying is calculated T is less than table T, therefore accept H0. So what is accept H0 means? The average thickness of insulating washers for electrical devices is 0.025. That is the deviation x bar minus mu is not significant.